So now I am going to discuss the concept of the matrix. So let's suppose there are the three individual ABC in a family, and A has a set of 3 pen, 3 set and 1 tie, and individual B has a set of 5 pen, 5 set and 2 ties, and individual C has a set of 6 pen, 8 set and no tie. So we can arrange this all the above data like this convenience system. So we take here the individual, right? Here the individual, and here we take the pens. Okay, the data of pens and data of the shirt and data of ties for the individual ABC respectively. Okay, so we denoted pens by P and shirts by S and ties by T. So along this horizontal axis the direction of row, and along the vertical axis the direction of actually column, right? So from the first row we can see that the individual A has the three pens, three shirt and one ties, and from second row individual B has the 5 pen, 5 shirt and 2 ties, and from the third row individual C has the 6 pen, 8 shirt and 0 ties, right? And the column, and from the first column give us just only the one uh, data. Okay, the data of pens for the individual ABC respectively, right? And from the second column we can see the all the data of shirt for the individual ABC respectively, and from the third column it gives us the data of ties for the individual ABC respectively, right? So the arrangement of numbers written in such a particular form of rows and column and enclose by this the square bracket and the large parenthesis is called a matrix. In general form the matrix form arranging in rows and columns are shown given below, right? So here we have m rows and n column. So this is a m by this is a m by n matrix. Okay, so it is said to be of the order of m by n, which is often written as m by n matrix. Types of matrix. Let's see the different types of matrix. Rectangular matrix. So a matrix of the order m by n is also called as rectangular matrix. And if m equal to m, where m is the number of rows and n is number of column, so then the matrix is the square matrix of order n. And the column matrix, so if the matrix consists of only one column just, so this is a column matrix or column vector. And null matrix, all the elements of a matrix are zero, then it is called the null matrix. We can denote it by this, the capital O. Okay, so such that this is an example of a null matrix, right? So if the elements of a matrix are not all zero, then it is called a non-zero matrix. So the negative of a matrix is we can denote minus aij m by order m by n, and is denoted by minus a. Let if we have a equal to this, uh, so we can write minus a just taking the minus sign of all the elements of our original determinant, right? So this is the negative of a matrix. And the transpose of matrix. The transpose of a matrix A is the matrix obtained from the given matrix delta by changing its rows into columns and column into rows, and it is denoted by A dash or A to the power T. T denoted here the transpose of A matrix, right? So hence if A be the matrix of order m by n, then A transpose is order n by m, right? So thus the transpose of this matrix will be this, just here changing the first row into the first column, second row into the, sorry, just change the first row into the first column and the second row into the second column. So note that the A transpose to the power transpose is the original matrix. Okay, and the diagonal matrix. So if all the off diagonal elements of a square matrix are zero, then that matrix is a diagonal matrix. Okay, so for example here, so here just the diagonal elements are non-zero and others elements are zero. The off diagonal elements are zero. So this is obviously a diagonal matrix. Okay, and the scalar matrix. So if the diagonal elements of a diagonal matrix be all equal, and then the matrix is called a scalar matrix. So here the all the diagonal elements are equal. Okay, so is a scalar matrix of A. Identity matrix. So if the diagonal elements of a diagonal matrix are all equal to 1 and it is denoted as unit matrix, sorry, it is defined as a unit matrix or identity matrix. So a unit matrix of order n is denoted by In or in bracket I or simply by I. Thus, this is A is our matrix. We can write it as follow. So as an identity matrix if and only if the condition Aij equal to 0 for I is not equal to j, where I is uh, indicate the rows and j indicate uh, the column, the value of column, right? I is indicate the rows and j indicate the columns. So and Aij equal to 1 for I is I equal to 1, right? So here this is this matrix is an identity matrix of order 3, right? So here the diagonal elements are 1. Okay, so this is our identity matrix, right? And matrix relation operation, equality of matrix. So two matrix AB are said to be a conformable of for equality if they are same order. So two matrices of same order are said to be equal if and only if the corresponding elements of two are equal. Here these matrices are actually equality. So this is the equality of this matrix, right? Addition subtraction of matrix. So if the matrix A B are the same order m by n order, then they can be added or subtracted by this. So if A is the first order, B is the second sorry also first order matrix. Okay, one by one, A is one by order 1 by 1 matrix and B is also order 1 by 1 matrix. So then A plus B will be Aij plus Bij and A minus B will be Aij minus Bij, right? So example, let's suppose here we have a here we have the 2 by 3, the order of 2 by 3 matrix, right? So addition of this both matrix, just the first element with the first, second element with second, third element with third, right? So we have this and some property. So a plus b equal to b plus a. So where a and b are uh, different matrix actually. So the matrix addition is follow a commutative laws. Okay, and a plus b plus c, we can write it a plus in bracket b plus c, where c is the third matrix. So matrix addition is also follow the associative